Okay, so let's imagine this is what you do. Somebody stands here and measures the angle, and I'm just going to make these dimensions up. So let's imagine that angle is 10 degrees. Let's imagine the height from the feet to the eyeball is 1.5 meters. Let's imagine that the length from here to here is 3 meters, and the length from there to there is 11 meters. So let's imagine that you can measure appropriately. Now, huge question, overwhelming question, but in amongst it I've found calculate the height of anchor point A. So this height here. So listen, if you can find something you can actually do, please do it. So calculate the height of anchor point A. So how are we going to do that? So we're going to get this wee triangle, which has our 10 degrees, and it has the length from here to here will be the same as this length, so that's going to be 11 meters. Now we're trying to find this length here. I'm going to call it X. So how do I find X? Well, I'll label my triangle. So that's 10 degrees, that's opposite, that's adjacent, that's hypotenuse. If I think of so katoa, so and ka both have H in them, and H I don't have and I'm not interested in, so it's tan, so it is toa. So I know that tan theta equals, oh hang on, let's cover up the one we're trying to find, the O, so opposite equals tan theta times adjacent, so X equals tan 10 times 11, so we get our calculator out, and as always we find if we go sine 30 it's actually rubbish, so we need to go shift set up, and we need to make sure that we are in degrees. And if we execute we get 0.5, so we're happy. And now we go to times 11, and that's 1.94. So this here is 1.94 meters. So AB, so that's this length here, equals 1.94 plus 1.5, which equals the height of laziness plus 1.5, 3.44 meters. So now what I've done is I have used trig to find the height of the pole. So I've got 1 out of my 3. Now I've got my height of the pole. This will determine, okay, that's fine. Find all the dimensions to determine the size and shape of the solar sail. Okay, so now the next one I'm going to find is this here. Now, I want that a different colour here. So this purple one, I've got the height. I'm going to put that like that, purple. That's a right angle triangle. This is 11. And this is 1.94. So I'm going to call that A, B and C, and I'm looking for this length because I'm looking for the dimensions of the solar sail. So I've got C squared equals A squared plus B squared. So C equals 11 squared plus 1.94 squared, and take the square root of the lot. So I'm going to go bracket 11 squared plus 1.94 squared, take the square root, and I've got 11.2. So that's 11.2 meters. Oh, it's not, is it 1.94? No, it's 3.44. Now, if I did that I would get away with that anyhow, because that wouldn't make me fail. So we'll click here that, okay, I've made an error, but I've used Pythagoras. And that says BE. We actually haven't done that dimension, but that's okay, because we've actually done AC. So this here, which we've called C, is actually AC. But that's okay, we've done some calculation, we just did the wrong thing input. Now, uses trig to find an angle of the shade sail. So, if we've got this length, then we can get this length. Now, in order to get this length, we actually need to get that one and that one, calculate that using Pythagoras. So it all gets very confusing. Perhaps the angle that it sits above the ground would be of interest. So even if we calculated that it's sitting at that angle from the ground, we could get credit. Alrighty? So let's try that. Get rid of some of that so that we can actually do it. So we're going to find the angle that it's coming off the ground. So let's draw our thing. This is our pole, and our pole was 1.94 plus 1.5, and our base was 11 meters, and we're looking for that angle there. So how do we get that angle? Well, that's the opposite, that's the adjacent, and again it's tan theta equals opposite over adjacent, so theta equals undo tan opposite with our 1.94 plus 1.5 over 11. So let's go here and clear and go inverse tan, shift tan, bracket, I'm going to double bracket 1.94 plus 1.5, close the bracket, divide by 11 and close the bracket, and I get a 17.4. So theta equals 17.4 degrees. Now, given that that was 10 degrees, I think that seems reasonable enough. Okay, so that's as much as you would need to do to actually pass.